what is the difference between 3x plus 2 and the 3x minus 3 equals 4? That's right. A is an expression and B is an equation because of this equal sign. So what is an equation? That's correct. Equation is a statement of equality between quantities. Okay, so an equation is a statement of equality between two quantities. Actually, if we have A is equal to B, that's an equation. If we have A is equal to A, that's still a statement of equality between a quantity and itself. Okay, so later on we will understand that there is what we call a property, which is reflexive property. There are two types of equations. One is the identity equation. Okay. An equation is identity if it is true for all permissible values of the variable or variables in the equation. So we emphasize here permissible values because sometimes there is a condition that the value must be integers only, must be rational numbers only, must be real numbers. So if the condition say for all integers and the equation works for all integers, then that equation is identity equation. If there is a condition that the variables, that the values is set of real numbers and all set of real numbers will satisfy, okay, for every real number you pick and that would satisfy the equation, then that equation is an identity equation. Example, x plus 5 equals 4x plus 2 minus 3x plus 3. So if you try to substitute, let's say x equals 1. So what will happen here is 1 plus 5 equivalent to 4 times 1 plus 2 minus 3 times 1 plus 3 is 6 equivalent to 4 plus 2 minus 3 plus 3. This is 0 and this is 6. Yes, 6 equals 6. So 1 here would satisfy the equation because the left side is equivalent, the right side. Okay, so if we solve that one using our previous knowledge, so we can have, let's say, x plus 5 equals 4x minus 3x, that's x. 2 plus 3, that's 5. So x plus 5 is equal to x plus 5. So in this case, whatever value you put on x, whatever real number you put on x, the left side will always be the same with the right side. So that kind of equation is called an identity equation. The second type of equation is conditional equation. Conditional equation is only true for some value or values of the variables. In the equation. Example, x plus 5 equals 3. Okay, so if we find the value of x, it is x is equal to 3 minus 5, x is equal to -2. And the solution for this is -2. It means that this equation is only true for x equals -2. Okay, it doesn't work for x equals -7 or x equals 10. Okay, so therefore it doesn't work for all real numbers, for all values of x. So therefore this equation is an example of a conditional equation. The value of the variable that makes the equation true is called a solution to the equation. A solution to the equation. Then the set of all solutions, is known as the solution set of the equation. Known as the solution set of the equation. Okay. For example, if the solutions are, let's say 3 and 5, then the set can be written as 3, 5. Okay. So meaning you are putting all the elements or all the values of x that would satisfy the equation in one set, and that is called the solution set of the equation. Now, if the equation has no solution, the solution is called empty. Okay, it can be written as empty, or the solution. So if the equation has no solution, the solution set is empty. Okay, or it can be written as the solution set is an empty braces, or the solution set is an empty form. That's simple. Now, equations can be expressed in a simple or complicated one. So in that case, how do we find the solutions to the equations? How do we solve the equations? Okay, so when we are asked how do we solve equations, meaning we are asked to find the solution set or the solutions to the equation, meaning finding the values of x that would satisfy the equation. But before that, let's review first the properties of equality of real numbers. Okay, properties of equality of real numbers. But what are real numbers? Okay, that's correct. Real numbers are union of irrational numbers and rational numbers. But what are rational numbers? What are real numbers? That's right. Integers are real numbers. Whole numbers are real numbers. 0 is a real number. So how do we arrange these real numbers, the hierarchy of numbers? So let's have a review first on the hierarchy of numbers. Okay. So example, these are stones. Example, these are stones. How many stones do we have here? Okay. That's right, that's 7. But how do we count? Okay. Correct. So we count from 1, 2, 3, and so on. We don't count from 0, 1, 2. We don't count from 1/2, 2/5, 1, 7, and so on and so forth. Or we don't count from 1.9, 1.89, 1.99, and so on and so forth. So we count by 1, 2, 3, 4, 5, 6. These numbers are called counting numbers. Those numbers from 1, 2, 3, and so on are counting numbers. And counting numbers are also called natural numbers. Okay. So imagine we have a real line. Imagine we have a real line. Okay. So counting, we have 1, 2, 3, 4, 5, and so on. Now in that real line, there is also 0 from the left of 1. So meaning, if we arrange this one, if we have here the natural numbers is denoted by n. If we get the union of the natural numbers and 0, the result would be whole numbers. Whole numbers, or this is denoted by capital W. So from 0 to 1 to positive infinity, these are whole numbers. Okay. However, from the left of 0, you can also find the negative numbers. Okay. They look like the whole numbers, but they are negative. So if we take these negative numbers, and the whole numbers, the result would be the integers. Okay, denoted by capital Z. That's why the negative numbers are also called negative integers. Now in this real line, if we go back to real line, between 1 and 2, you can also find numbers. Example, we have here 1 and 1/2. Okay, we have 1.1, 1.3. Okay, the fractions. Okay, there are also numbers called the fractions. Example, 1/2, 1/3, 2/6, 3/7. These are fractions. So if we get the union of fractions and the integers, we have the rational numbers. Okay, this is denoted by capital Q. However, in this real line, there are also irrational numbers. Example, those decimals that are non-repeating and non-terminating. Okay, example, we have pi. That is non-terminating, non-repeating decimal. Example, we have square root of 2, square root of 3, or square root of p, where p is prime. So these numbers also exist in the real line, and these numbers are called irrational numbers. Irrational numbers. Now, if we get the union of the irrational numbers and the rational numbers, then that's real numbers. Okay, denoted by capital R. So meaning all integers are real numbers, all whole numbers are real numbers, all natural numbers are real numbers. 0 is also a real number, as what we have mentioned a while ago. Now, if we extend this one, if we continue this one, there is also what we call imaginary numbers. Imaginary numbers, those with I. Example, 4i. Square root of -1, which is I. That is an imaginary number. Now, if we get the union of the imaginary numbers and the real numbers, what we have would be the complex numbers, denoted by capital C. Okay? So here, in this course, most often we will be dealing with real numbers. Okay? If we mention, let's say, if we discuss and we mention numbers, it means we are actually stating real numbers. Okay, you don't have to state every now and then real numbers, because if we mention numbers, that means we are talking about real numbers. So again, going back to the properties of equality of real numbers. So what are the properties? This is still a review from your previous mathematics. Properties of real numbers. So let A, B, and C be real numbers. One property is reflexive property. Reflexive property says that A is equal to A. 5 is equal to 5. -1 is equal to -1. That is reflexive property. Second, we have symmetric property. Symmetric property says that A is equal to B if and only if B is equal to A. Okay, in mathematics, this symbol is if and only if, read as if and only if. It means that if A is equal to B, then B is equal to A. And if B is equal to A, then A is equal to B. Okay, in short, A is equal to B if and only if B is equal to A. That is symmetric property. Third is transitive property. Transitive property says that if A is equal to B, if A is equal to B and B is equal to C, then A is equal to C. Okay. Then the fourth one is addition property. This is very important. This is one of the properties that you really have to remember. The addition property of equality. So we have two cases here. If A is equal to B, then A plus C is equal to B plus C, or A minus C is equal to B minus C. It only means that whatever real number, whatever number you add on the left, you also add it on the right, or whatever number you subtract on the right of the equation, you also have to subtract it on the left of the equation. So meaning, whatever values you put on both of the equations, the truthfulness of the equation does not change. Okay, does not change. The equality does not change. Also, if A is equal to B and C is equal to D, then A plus C is equal to B plus D, or A minus C is equal to B minus D. Okay, almost the same case with the first one. However, we have an emphasis here that there is another number which is D and equivalent to C. Then the fifth property, which is also important, very important, is the multiplication property. Multiplication property says that if A is equal to B, then A times C is equal to B times C, or A over C is equal to B over C, where C is not equal to 0. So it is very important to emphasize that C is not equal to 0, because if C is equal to 0, then that expression becomes undefined. Or if the numerator is also 0, that expression becomes indeterminate. Then the second case for this, if A is equal to B and C is equal to D, then A times C is equal to B times D, or A over C is equal to B over D, where C is not equal to 0 and D is not equal to 0. So these are very important properties to remember in solving equations. So first, we will solve linear equations in one variable. Okay, our first topic would be solving linear equations in one variable. Okay. Linear equations are also known as the first degree equations. First degree equation. So what is a linear equation? A linear equation in one variable is given by ax plus b equals 0, where a and b are real numbers and a is not equal to 0. So meaning, when we ask to solve this equation, this linear equations, we are asked to find the value of x that would satisfy the equation. Now, if we take this ax plus b equals 0, if we apply the properties that we had a while ago, we apply the properties, the addition, the multiplication, then we will be able to find the value of x. So in this case, let's apply first the addition property of equality by adding negative b on both sides to eliminate b on the left side of the equation. So this can be written as ax plus b minus b equals 0 minus b. So meaning we are adding here negative b, which is the negative of b. We do that so that we will eliminate the positive b on the left side of the equation, so that what will remain afterwards is only our variable, our x. Okay, so that is the addition property of equality, which says if a is equal to b, then a plus b is equal to b plus c. So here we have ax is equal to negative b. Next, we divide a on both sides of the equation by applying multiplication property of equality, so which makes it a is equal to b, which is equal to negative b over a. Okay, so again guys, we are not saying it's transposition. Transposition is the term used in the concept of matrix or matrices. Okay, you might think that we transferred the positive b to the right to make it negative b and we call it transposition. Actually, it's not transposition, it's addition property of equality. However, some just considered it like that because mentioning addition property of equality is too long. Okay, but in this class it doesn't matter whether you call it or not, so long you are doing it right, the operation is correct, and the steps does not violate the equation. If it still works, then that would be fine, whatever you call it. But the right way, it's called addition property of equality. So in this case, in the equation which is ax plus b equals 0, the solution is negative b over a. So we can write the solution for that kind of equation is negative b over a. Example, if we have 2x plus 5 equals 6. Question, is this in the form of ax plus b equals 0? The answer is no, because here we have 6 instead of 0. So if we try to use this process, we can equate this 2x plus 5 equals 6 to ax plus b equals 0 by eliminating 6 on the right side. So we have 2x plus 5, eliminating 6 is subtracting 6 on both sides of the equation. So this makes it 2x minus 1 equals 0. So now it is already in the form of ax plus b equals 0, where a is 2, your b is negative 1, and then remember the solution set is negative b over a. So therefore this can be written as your b is negative 1 over 2, or this is 1/2. So therefore 1/2 is the one that would satisfy 2x plus 5 equals 6. However, if you don't want to memorize or to remember that the solution set is negative b over a, then you can just simply solve it freely by using the addition property of equality and the multiplication property of equality if it's necessary. Okay, so here we have 2x plus 5 equals 6. Okay, to remain x on the left side, we do the addition property of equality to remove the 5. So we have 2x plus 5 equals 6. Removing 5 is adding negative 5 on both sides. So we have 2x equals 1. Then divided by 2, on both sides, multiplication property of equality, then x is equal to 1/2. So therefore, the solution for that equation is 1/2. They are just the same. Another example. Example 2, we have 3x plus 2 over 4 equals 2x plus 1 over 3. So here, to make it easier, if we encounter equations with fractions, meaning we have denominator which is not equal to 1, then the easiest way is to eliminate first the denominator. So the ideal way, or the best way of doing it, is finding the LCD of the denominator. Our denominator would be 4 and 3. And the LCD for that is 12. So we can multiply 12 on both sides, okay, by multiplication property of equality. So we have 12 divided by 4, 3. So that makes it 3 times 3x plus 2 equals 2x plus 1 equals 4. Okay, recall that we have distributive property. If A is equal to B plus C, A times B plus C can be written as A times B plus A times C. Okay, this is distributive property, so we can apply it here. So we have 9x plus 6 equals 8x plus 4. Now, we can combine the variables on the left side and the constant on the right side by, again, applying the equality, the multiplication and the addition property of equality. So we have, after doing it, we have 9x minus 8x equals 4 minus 6, which is x is equal to -2. So therefore, the solution for this is -2. Now, what will happen if we have too many fractions in the equation? So we'll be finding the LCD of those denominators. However, if you think it's too messy in finding the LCD, then we can do the simpler method, but it's quite longer in the solution, but you can be certain that what you are doing is correct. So how is that possible? Okay, how does it work? Example, in our previous example, again, 3x plus 2 over 4 equals 2x plus 1 over 3. If finding the LCD is too messy for you, then you can just do eliminating the denominator one by one by applying the multiplication property of equality. In this example, we can multiply 4 first on both sides of the equation. So this makes it 3x plus 2 equals 2x plus 1 times 4 over 3. Then, multiplying 3 on both sides of the equations to eliminate 3. So that makes it 9x plus 6 equals 4 times 2x plus 1. Then we have 9x plus 6 equals 8x plus 4. Then addition property of equality, we have 9x minus 8x equals 4 minus 6. X is equal to -2. And your solution set is -2. So you will have the same answer, whether you use the LCD or this one. Now, if you are not comfortable finding the LCD, if it's too messy for you, then you can use this method, one by one process, or one by one way of eliminating the denominators. Okay, that's still correct, but it would only take longer solution, but you can be certain. You can be so sure because you eliminate one by one. Another example. 2x minus 3 over 4 plus 2 over 3 equals x plus 1 over 5 minus 1. Okay, example, in this one, we have three fractions, meaning we have three denominators, 4, 3, and 5. So you have to find the LCD of 4, 3, and 5. However, again, if you don't want to find the LCD, then you can just multiply one by one. Okay, you can eliminate the denominator one by one. 2x minus 3 over 4 plus 2/3 equals x plus 1 over 5 minus 1. You can multiply 4 first to eliminate 4. So we have 2x minus 3 plus 4 times 2 over 3 equals 4 times x plus 1 over 5 minus 4. Then eliminate 3 by multiplying 3 on both sides. So we have 6x minus 9 plus 8 equals 3 times 4 times x plus 1 over 5 minus 12. Then eliminate 5 by multiplying 5 on both sides of the equation. So we have 30x minus 45 plus 40 equals 3 times 4 is 12 times x, 12x plus 12 minus 12 times 5, 60. So you can simplify this one. So right now we don't have already a fraction, meaning we don't have a denominator which is not equal to 1, because obviously all of them have a denominator which is 1, so we don't have to write that one. So it is easier now. So we have 30x minus 5 equals 12x plus minus 12x minus 48. So we combined, so we have 30x minus 12x minus 48 plus 5. So 30 minus 12, that's 18x equals negative 43. Okay, and then divided by 18 on both sides, we have x is equal to negative 43 over 18. So therefore your solution for this is negative 43 over 18. Again guys, you are allowed, that's the ideal way. You can do the LCD. You can multiply right away LCD on both sides of the equation to eliminate all the denominators which is not equal to 1. Okay, that would work, and that's the ideal. Now if you are not comfortable with it, if you want to be so sure in eliminating the denominator, you can use this one. Okay, that's also fine. You will still arrive with the right solution, so long you are not careless with the arithmetic and the distribution of the numbers inside the parentheses. You have just to be very careful on that. Now what will happen if it involves a decimal? Example, 0.2x equals 5. So ideally, we can just apply the multiplication property of equality. 0.2 divided by 0.2. However, dividing a number with a decimal is quite messy. Oh, that's an elementary lesson, but that's quite messy. So the best way of doing it is eliminating the decimal by multiplying multiples of 10 on both sides. Okay, what does it mean? What does it mean? So we have 0.2x equals 5. So eliminate 0.2 on that. We can just multiply multiples of 10. Okay? What does it mean? Remember, our decimal is 0.2. Okay? There is only one number after the decimal. So we can multiply 10 because that is multiplying 10 to the n. The n here means the number of zeros or the number of numbers after the decimal. So in this case, since we only have 1 after decimal, then we can just multiply 10. So that makes it 2x equals 50. In this case, we can just divide 2 on both sides. That makes it x is equal to 25. And the solution set is 25. So meaning if this is 0.002x equals 5, what we're going to do is we multiply 10 depending on the number of digits after the decimal. In this case, we have 3. So we multiply 1, 2, 3, 1,000 on both sides. Okay? To make it 2x is equal to 5,000. And then you proceed with your solution using the properties of equality. Another example. We have x plus 4 over 2. No. We have x plus 2 equals 2x plus 3 over 2 plus 0.5. So in this case, we have a fraction. At the same time, we have a decimal. So you can eliminate first the denominator or you can eliminate first the decimal. So it's up to you. For me, I prefer eliminating first the decimal by multiplying again 10 because there's only one digit after the decimal. So we have 10x plus 20 equals 10 divided by 2, that's 5. So you can just multiply 5 here. 5 times 2x plus 3 plus 5. By eliminating the decimal, we also have eliminated the denominator because it happened that the 10 is divisible by 2. So we can simplify 10x plus 20 equals 10x plus 15 plus 5. So this is 10x minus 10x equals 15 plus 5 minus 20. 0 equals 0. Okay. Now, 0 equals 0, meaning whatever the values of x you put here on the left side will always give the values of the right side. So meaning any real number that you can think of and you substitute that one to our x, the right side will always be the same with the right side. In this case, again, any real number. So meaning all real number, every real number you can think of, then it's a solution. So therefore, the solution for this is all real numbers. Okay? So don't make a confusion, don't make a mistake that sometimes students, if it's 0 equals 0, they put the solution set is 0. That's wrong. This one here, if you end up x equals 0. Okay? However, if we have 0 equals 0, in this case alone, 10x plus 20, 10x plus 20. So meaning the equation is, the left side is equivalent to the right side in any case of x. Okay? So that means 0 equals 0. So therefore, the solution for set for that is all real numbers, not this one. Then another example, one last example before we proceed to our next equation. Let's have 14 minus x over 2 plus x equals 1 plus x over 2. So we have 14 minus x over 2 plus x equals 1 plus x over 2. We can eliminate 2 on both sides by multiplying 2. So we have 14 minus x plus 2x equals 2 plus x. Then, combining the variables, minus x equals 2 minus 14. Negative x plus 2x minus x, that's 0, equals negative 12. Question, is 0 equals 12? The answer is no. So meaning, you cannot find a real number that if you substitute that one to our x, the result is correct. The equation is correct. Okay? So meaning, there is no real number that you can substitute to our variable that makes the equation correct. So in that case, our solution is empty. Or the solution is empty. Okay? An empty solution is also a solution. Okay? A no solution is also a solution in mathematics. Question on that. Okay. Another equation is literal equation. Or equations. A literal equation is an equation where some or all quantities are expressed in terms of letters. Example, we have this one, the area of the rectangle. We have so these are examples of literal equations. So we have f is equal to 1 over 1 over a plus 1 over b. So these are examples of literal equations. So for this, for example, for a is equal to L times W, say solve for W means we are expressing W in terms of the other letters in the equation. So here we can just apply the multiplication property of equality by dividing L, where L is not equal to 0. So here we have A over L is equal to W, or we can write this one as W is equal to A over L. That's symmetric property. Okay, so yeah. Another example for this one, V is equal to 4 over 3 pi r cubed. Okay. If we are asked to solve for r, meaning find or express r in terms of the other variables, in terms of v, in terms of the pi there. So we can just have v is equal to 4 over 3 pi. So we can eliminate the 4/3 pi on both sides of the equation by multiplying 3 over 4, by multiplying 3 over 4 pi on both sides of the equation. which makes it 3b over 4 pi equals r cubed. Now from here, we can just apply cube root property. So we have cube root of 3v over 4 pi equals r. Or you can write this one as r equals cube root of 3v over 4 pi. That's symmetric property. Another example here, if you have f equals 1 over 1 plus a plus 1 plus b, then solve for, let's say, b. Okay, you can just use our technique, or you can use the LCD and the elimination of the denominator. So here, f equals 1 over a plus 1 over b. Take note, this 1 over a plus 1 over b here is the denominator of 1. So we can just multiply 1 over a plus 1 over b. 1 over a plus 1 over b to eliminate this denominator here. So that makes it f over a plus f over b equals 1. So next, you can multiply by the denominator, which is ab, or you can multiply a first, then b first, the one that we did a while ago. So we can have fb plus fa equals AB. Then since we are asked to solve for b, we can combine those variables with b terms. So we can combine that one on the left side. So we have fb minus ab by applying addition property of equality minus fa. Then you can factor out b on both sides. On both terms, we have f minus a equals negative fa. Then divide f minus a on both sides. We have b equals negative fa over f minus a. Or you can write this one as negative fa over f minus a. Okay? Now, if you have a solution like b equals fa over a minus f, that's the same. Okay? They are just the same.